When Elon Musk announced that his factories would be able to produce one car every 40 seconds, the automotive industry responded with skepticism. The biggest manufacturers with century-long histories didn't take it seriously, but that very arrogance could cost them the market, because Tesla is already changing not the car itself, but the very essence of how cars are built. For over 100 years, the global auto industry operated on the same model. Thousands of individual parts are manufactured at different facilities, then shipped to an assembly line where hundreds of robots weld them together and thousands of workers sequentially assemble unit after unit. Toyota, Volkswagen, Ford, General Motors, they all followed this logic for decades. It had been refined to perfection. It seemed like nobody could come up with anything better. Musk asked a different question, not, how do we assemble a car faster? But why assemble something from 100 parts at all when you can cast it as one piece? That question, almost embarrassingly simple, triggered one of the most radical manufacturing revolutions in automotive history. The answer was the gigapress, a massive casting machine capable of using enormous pressure to turn molten aluminum into a single unified part. Where dozens of separate metal stampings and hundreds of welds were once required, a single monolithic structure now takes their place. Several generations of these machines are already running in Tesla's factories, and next-generation versions are expected to deliver even higher clamping force. At first glance, it looks like a simple engineering improvement. In reality, it's a systemic shift. At Tesla's factory in Texas, implementing the gigapress eliminated roughly half of the welding robots. Fewer parts means fewer joints means fewer defects, and fewer defects means lower production costs. Buyers don't see any of this, but it's exactly what affects the final price of every car. But the gigapress is just the first step. Tesla is going further with a concept the company calls the unboxed process. Here's the idea. Instead of running a car through hundreds of meters of sequential assembly line where every component is installed in strict order, Tesla breaks the vehicle into 6 independent modules. The front body section is assembled in one zone, the rear in another, the battery pack on a separate line, and the interior in parallel on its own station. All modules are produced simultaneously and only joined together at the final stage. By Tesla's calculations, this approach cuts manufacturing costs in half, reduces factory floor space by nearly 40%, and increases production throughput by a third. The first car to roll off the line under this system is expected to be the Cybercab. Musk has cited a target production cost of around $30,000 per unit, with the potential to drop further as the process scales. The full launch of the unbox process is planned for around 2027. While the new system is still being refined, the heart of production remains what's known as the body shop. This is where automation reaches its limits. Unlike final assembly, where people and robots work side by side, the body shop is an almost entirely robotized environment. Hundreds of robotic arms run around the clock, performing thousands of welding operations on each body with precision down to fractions of a millimeter. This is exactly what Musk was referring to when he called the Tesla factory the machine that builds the machine. The robots here use several joining technologies simultaneously. Resistance spot welding secures sheet metal at thousands of critical points. Laser welding is used where maximum precision is needed. It produces a cleaner, stronger seam. High-strength structural adhesives are also applied, increasing the body's torsional rigidity and reducing vibration. This combination of technologies is one of the reasons Tesla vehicles consistently score high in crash tests. The key advantage of robots here isn't speed, it's repeatability. A skilled worker can perform excellently, but after many hours of continuous work, tiny deviations are inevitable. A robot reproduces the exact same motion thousands of times without any loss of precision. That guarantees every body leaving the shop meets the same quality standard. After the body shop, the car moves into the paint shop, one of the most technologically complex areas in the entire factory. Here, even a microscopic dust particle can ruin a finish and send a body back for rework. That's why temperature, humidity, and air cleanliness are controlled with pharmaceutical-grade precision at every stage. The process begins with a thorough cleaning of the body to remove any contaminants left over from manufacturing. The body is then submerged in an electro-deposition primer bath known as e-coating. This method applies a uniform anti-corrosion coating to all metal surfaces, including hard-to-reach areas that a spray gun simply can't get to. It's one of the key steps that provides long-term protection against moisture, road salt, and corrosion. A primer coat follows, creating a reliable bond between the metal and the finish coat. Only after that do robotic systems apply the color layer and clear coat. Each layer is baked in an oven at a precisely controlled temperature. The result is a smooth, glossy finish built to last for years of use. One interesting detail, the paint shop is one of the few areas where several Tesla models pass through a shared line before splitting off onto separate assembly tracks. The Cybercab will be an exception. Tesla plans to integrate color and protective coating directly into the casting process, eliminating traditional painting entirely. But it's worth pausing here on one episode that often gets glossed over, and it shouldn't be. In 2018, in the middle of the Model 3 production ramp, Musk set a goal of producing 5,000 cars per week. To get there, he decided to automate the factory in a way nobody in the industry had dared to. Robots were given tasks traditionally performed by people, routing wire harnesses, installing interior components, transporting parts between stations. On paper, it looked flawless. In practice, it turned into a disaster. Robots handled rigid, geometrically predictable components just fine, but with flexible materials, wiring, insulation, they couldn't cope. The slightest shift of a part by a few millimeters would bring the entire line to a halt. The conveyor would stop. Unfinished cars sat on the floor. Spare parts to repair the robots had to be sourced from overseas. Musk acknowledged the mistake publicly. In a social media post, he wrote, "Excessive automation at Tesla was a mistake. To be precise, it was my mistake. Humans are underrated." For someone who very rarely admits missteps, that was an extraordinary statement. But that very failure became one of the most valuable lessons in the company's history. From that point on, Tesla rebuilt its entire manufacturing philosophy around one principle: robots where they objectively outperform humans in heavy, repetitive, high-precision operations, welding, lifting bodies, transporting large assemblies, die casting. Humans where adaptability, dexterity, and real-time decision-making are required. That is Tesla's real competitive advantage, not design, not marketing, and not even battery range. The real battle in the auto industry is being fought over production costs. The company that can build cars cheaper than anyone else gains the most freedom in pricing, capturing market share, and funding the next technological leap. Tesla has demonstrated this strategy repeatedly, adjusting prices across different markets and putting pressure on competitors who simply can't afford to do the same. If the unbox process hits its target numbers, the gap between Tesla and other manufacturers in terms of cost will grow even wider. And then the question won't be who builds the best electric vehicle, but who can survive this race at all. If you're interested in how engineering decisions reshape entire industries, hit like and subscribe to the channel. There are plenty more stories ahead about technologies that are rewriting the rules of the game.